All right, good day everyone. Today we are talking about section 6.7, factor special products. I can factor using special patterns, I can factor using any method. So today we're going to be looking at really one special pattern and one kind of review of factoring. So if you remember way back when we talked about multiplying stuff, we talked about there's a special pattern if you remember it. If you don't, how you can just multiply. So what I'd like you to do is multiply these out using area, split, stack, or FOIL. So pause the video and multiply each of these three. And on each of these, you may have remembered that your middle terms canceled, and those terms canceled, and those terms canceled on all these, because we called this the sum and difference pattern. That if you saw the sum and difference, you could use the pattern of the first term squared minus the second term squared. If you didn't recognize this, that don't matter, it just multiply it out. Well, today we are talking about the difference of squares, which is the factoring side of this. So if you see that you can rewrite this as a quantity squared minus b squared, it factors to be a plus b, a minus b. Now, I will say you must write this as a squared minus b squared first before you can use the pattern. You can't just go equals the answer. So when we're doing these problems, we're going to say, first thing you have to check, is this something squared minus something squared? Which the answer is yes. So then we go, what do we square to get y squared? Well, y. What do we square to get 16? 4. So this first parenthesis acts as A, the second parenthesis acts as B. So the sum and difference pattern, or what we call the difference of squares, on the factoring end, is A plus B. So the first parenthesis plus the second one. So y plus 4, and then the second parenthesis is going to be the subtracting of it, y minus 4. So we get an answer of y plus 4, y minus 4. And again, so what you're looking for, what do you square to get w? Well, I'm sorry, what do you square to get w squared? That's w. What do I square to get 25? So w plus 5, w minus 5. Again, you hear me refer to it as this squared minus that squared becomes this plus that, this minus that. The two parentheses are almost the same except one is plus, one is minus. All right. And so when you have something and you're like, okay, this isn't obvious, I have to go, is this a perfect square? Is 25 a perfect square? Yes, it's 5 squared. So 25m squared would be 5m quantity squared. What do I square to get 36? 6. So I'm going to have 5m quantity squared minus 6 squared. Again, this plus that, this minus that. So this squared minus that squared becomes this plus that, this minus that. So 5m plus 6, 5m minus 6. When you are doing these, there's always the trick to remember of GCF first. So while I look at 4b squared minus 100 and go, oh, I want to factor that, I always have to check, is there a GCF? In this case, 4. So I'm going to factor out 4 first. And then I'm going to say, is this a difference of squares? Is b squared a square? Yes. Is 25 a square? Yes. And when I'm talking about squares, I'm talking about numbers that are perfect squares. And for those of you that have been wondering about the white numbers along the front of my room, those are the perfect squares. And again, the pattern, this plus that, this minus that. And don't forget to bring down that lazy friend, your GCF. So that would be your answer. On something like the middle one, if you wanted to rewrite this in standard form, you could and say this is negative 18n squared plus 8, or you could factor it as it is. I personally tend to rewrite it in standard form and then factor. So I'm going to factor the one in the red that's on the right. So I know my GCF is negative. What number goes into both 18 and 8? Well, they're both divisible by 2 because they're even. So I'm going to take out 2 and I'm left with 9 squared minus 4. Is 9 a perfect square? Yes. I square 3 to get that. Is 4 a perfect square? Yes. I square 2 to get that. So 3n plus 2, 3n minus 2, and then I bring down my GCF. All right, same concept here on the last one, so pause the video and try that one on your own. Again, we factored out a GCF of -2. An indicator that there's probably a GCF or something I need to do is it's an adding problem. In order to be a difference of squares, the two terms need to be subtracted. Also, there's a negative out front. Whenever there's a negative out front, that means I have to factor out a -1 at least, unless there's a larger number that's common to both of them. In this case, -2 is common to both of them. All right. Next thing we're going to do is we're going to take this to the solving part. Use your difference of squares to solve it, or to factor it, I'm sorry. Factor it, and then set each part equal to 0 and solve. So you should be able to try each of these on your own. All right, so again, you're looking for this squared minus that squared. Write it as this plus that, as you can see in yellow here. And set each part equal to 0 and solve. So you get -10 on the left and 10 on the right. Again, writing your answers from smallest to greatest, smallest to largest. 7y quantity squared, 5 to get our 49y squared, 5 squared to get our 25, so we get 7y plus 5, 7y minus 5. We do the solving, we get -5/7 and +5/7. If you hadn't noticed this difference of squares pattern, you're always going to get the negative and positive of the same number. So on the left one here, the x one, we had -10 and 10. The y one, we got -5/7 and +5/7. And the m problem, again, we rewrote it in standard form, factored out the GCF, did the a squared minus b squared factoring, our difference of squares. Again, you had 0 equals -5, which is not true. That's why we have the x there. We solve the other two parts equal to 0 and get -3/4 and +3/4. All right. The next thing is to multiply out when we have a binomial squared. We talked about this a little bit in properties of exponents, how you do not distribute an exponent. We talked about this in section 6.2, where we said that we cross off the square and make another one. And then you can multiply it using area, split, stack, or FOIL. So I'd like you to pause the video and multiply each of these two out and check back. All right, so I use the area method on the first one. Again, you could use FOIL, split, or stack as well. But you should have gotten x squared plus 8x plus 16. And the one on the right, I did split this time to get 4y squared minus 12y plus 9. Again, you could have done FOIL, area, or stack as well. Now, there is, if you were to look this up online, there is patterns. So if you recognize a squared plus 2ab plus b squared, or a squared minus 2ab plus b squared, then these actually factor. This is a special factoring pattern. Really, what I'm going to say is, if you know how to factor, just like when we talked about the multiplying of this, if you know how to factor, just factor. Just like if you know how to multiply, don't worry about memorizing the special pattern, just multiply it. All we're going to do is we're going to say, when the sides of the diamond match, you could, and I'm just emphasize could, be working with a perfect square trinomial. Okay. We'll go through an example of this showing you how the diamond works. If you can use the diamond, you can use the diamond on this. All right. So again, we have y squared plus 24y plus 144. It's a trinomial. Since it's a GCF, or sorry, the leading coefficient is 1, we know there's no GCF. So we're going to go straight to the diamond. 144 and 24. So what numbers multiply to be 144 that add to be 24? In this case, you're going to recognize it's 12 times 12 is 144, and 12 plus 12 is 24. So when these numbers are the same, that's what I was talking about. When the sides of the diamond match, you could be working with the perfect square. Most of the time, it will be. Our variable is y, so we're going to get y plus 12, y plus 12. Or, since these match, you could say that this is y plus 12 quantity squared. And if you recognize that you can go from the diamond right down to this quantity squared one, that is the ultimate goal, but I will accept it written either way. Now, always remember GCF first. So like this problem, a lot of people say, oh, it's 2W, I need to do the diamond split. Not necessarily. Because if I factor out this 2, we have to ask, does 2 go into 24 and 72? And it does. So we're going to factor it out. This, all of a sudden, inside here is a diamond done. And again, I think everyone will agree, a diamond done is significantly easier than a diamond split. Again, a positive product, negative sum, so we know they're both negative. What numbers multiply to be 36 and add to be negative 12? Well, that's negative 6 and negative 6. So this becomes W minus 6, W minus 6. We bring down the GCF. That's an answer. Or we could say it's 2 times W minus 6 quantity squared. Now the last one. We have 25z squared plus 20z plus 4. No GCF. So I'm going to have to do diamond. 25 times 4 is 100. And 20. What numbers multiply to be 100 that add to be 20? Well, that's 10 and 10. Unfortunately, though, this one's not a diamond done because it's 25z squared, so we got to do 25z squared plus 10z plus 10z plus 4. Again, grouping the first two and last two terms, factor out the GCF. Don't know where I got W from, so 5z. Then we're left with 5z plus 2. And here we get what? Plus 2 and 5z plus 2. So our parentheses are 5z plus 2 from the outside pieces. The inside pieces that match were 5z plus 2. Or we could say it's 5z plus 2 quantity squared. Again, whenever the numbers on the side of the diamond match, you could be working with a perfect square. All right, if you have any questions about section 7, make sure you ask. This is one of those sections that people tend to make the most mistakes on. So if you're not understanding something, make sure you come to class with questions and ask, because these will be on the test. Have a great day, everyone.